All right, 5.4b, exponential functions, the integrals. All right, so if the derivative of e to the x is e to the x, the antiderivative of e to the x is e to the x plus c. So let's add to our note card right there. All right, pretty good. However, we can never forget the what rule? Chain rule. All right, let's do it. Let's do it. So this first one, I have the integral of e to the 3x plus 1 with respect to x. Well, what could I make my u if I'm going to use u substitution? What could I make my u? 3x plus 1. So what would be my du? 3 dx. The dx gets covered, but what needs to be brought out front? A 1/3. So now I have a 1/3 integral e to the u du. So I anti-derive, I end up with 1/3 e to the what? 3x plus 1, and then plus c. So this next one, we have 5x e to the negative x squared with respect to x. All right, so again, what could I make my u? I could make my u or negative x squared. So my du would be what? Negative 2x dx. Now, does it cover? It covers decent. All right, does it cover what I need it to cover? Yes, sure does. It covers my x and it covers my what? Dx. It just doesn't cover my 5. And so if it's just a constant multiple, that's okay. So what gets brought out front? Negative 5 halves. So now we have a negative 5 halves, the integral of e to the u du. And so now it's pretty simple. What's my antiderivative? I'd have negative 5 halves e to the negative x squared plus c. All right. All right, I'd like you to try A and B. All right, let's look at A. What could I make my u? 1 over x. If I make my u 1 over x, whoa, what happens? What's my du? Negative 1 over x squared dx. Does it cover what I need it to cover? Sure does. It covers it really nice. However, what needs to be brought out front? A negative. So now I have a negative integral e to the u du. And so what would my antiderivative be? A negative e to the 1 over x plus c. All right. All right, let's look at part B now. What could I make my u? Cosine x. So if I make my u cosine x, what would be my du? Negative sine x dx. Did it cover what I needed it to cover? Yes, it's not perfect though, so what needs to be brought out front again? A negative. So now I have a negative e to the u du. And so, what would I end up having now? Negative e to the cosine x plus c. All right, pretty good. All right, so now actually take an integral. We're actually finding what? Area under a curve. All right. All right. Because why do I have an elongated e? It's area with what? E now. How about that? All right, so let's do it. So now I have an integral from 0 to 1 of e to the negative x dx. All right. And we'll go both ways to Tampa here. So what could I make my u on this first one? Negative x. So my du is? Negative 1 dx. Did it cover? Not perfectly. So now I have a negative integral e to the u du. So what would be my antiderivative? Negative e to the negative x, and I'm going to go from 0 to 1. Now, I didn't change my limits on this one because I put it back in terms of x. You following me? I'm going to go both ways on this slide. All right. So now let's use our first fundamental. We substitute in 1, and so now we end up with negative e to the negative 1, and then minus, I substitute in 0, so now I have what? Minus a negative 1, exactly. All right, so we end up with 1 minus 1 over e. All right, and that is the area under the curve of that one. All right, let's look at part B. So now I have the integral from 0 to 1 of e to the x over 1 plus e to the x. All right. All right, so what could we make our u? What? 1 plus e to the x, exactly. All right, so what would be my du? E to the x dx. Did that cover? Perfectly? Yes, that covered actually perfectly. Now, I'm going to change my limits on this one.
Oh, well, a coin.
All right. What a coincidence. I agree. All right.
Where
Oh, a rare occurrence. All right. All right, so now I'm going to change my limits. I'm going to keep them in terms of u. So, what's my new lower limit? If I substitute in 0, what is my new lower limit right here? 2. 1 plus 1 is 2. All right, and then what's my new upper limit? 1 plus e. All right, so I honestly like changing my limits. I think it's actually a little bit easier. So now, what is my antiderivative du over u? Natural log of absolute value u. And I'm going to go from 2 to 1 plus e. All right, and so now I just substitute in 1 plus e. So now I have the natural log of 1 plus e, and then minus the natural log of 2. All right. Now, sometimes that won't show up as the answer. All right. What would they maybe do if it's a multiple choice question? What would they actually give as that answer? Natural log of what? 1 plus e over 2. That's what they'll give as an answer. You following me? All right, so they're going to use their pre-calc or algebra 2 properties on that. All right, let's look at part C. So now I'm going to take my integral from -1 to 0 of e to the x cosine e to the x dx. All right, so what could I make my u? What is my innermost composite? E to the x. So what's my du? E to the x dx. So this part gets covered. Does it get covered perfectly? Yes. All right. And so this is really going to be the integral of cosine of u du. Now, I'm going to go ahead and change my limits again. So what's my lower limit going to be? If I substitute a -1 for my x for u, what do I get? If I substitute a -1 right there, I get what? 1 over e. I get 1 over e. And then if I substitute in 0, what's my new upper limit? 1. All right. I think it's a little bit easier. All right. So then what is my antiderivative of cosine? Sine u in this case. And I'm going to go from 1 over e to 1. All right. So now when I substitute in, I end up with sine of 1 minus sine of 1 over e. All right. And that is the area under that curve. All right. Pretty good? All right. There you go. What's the antiderivative of e to the x? E to the x. However, what do you always have to remember? Chain rule.